Hey guys, welcome back. So, a few months ago, I picked up a Husky generator with a blown engine. It was only $65, and I wasn't expecting to fix the engine, really. I just picked it up for the parts. I made a video on disassembling that engine and sizing up the damage and realized it needed too much to make it whole again. It needed a new crankshaft, piston, and connecting rod, totaling about $300 in parts. And this generator, fully put together, would only sell for about $400. So that's fine. I got this machine for parts and it got put to good use. I actually used the power head to repower a storm responder with a bad power head. The receptacle box was also used on a generator that had a bad circuit breaker. And the actual frame itself, I swapped onto another generator that had a severely rusted and damaged frame. So yeah, fast forward a few months and I did locate a good used crankshaft that came from another blown engine. So I rebuilt this engine, but unfortunately everything else on that generator was pretty much gone at that point. But as luck would have it, somebody listed a Husky generator frame for sale for $35. And that's exactly what I need to get this project going again. So I picked up the frame. It has pretty much everything I need. It has the wheels, the axle, handles, the foot, and of course the frame itself. The engine also has been rebuilt and is ready to go. And although I used the power head on this generator for something else, I do have another one right there that will bolt on without issue to that engine, and I believe will also go on this frame without any modification. So I guess what I need to do before getting too deep into this is to just kind of go through my bins of spare parts and make sure I have all the bits I need to put a working generator together. So I'm going to hit pause here for a second. We'll dig out some parts and see if we have everything we need. I think I'm going to be able to pull this one off. We have a tank, the heat shield, the bolts for the tank, the bell housing, the bolts for the bell housing, a set of brushes, engine mounts, and an electrical box. Now, these are actually two different boxes. This is the one here that we need. It has the correct hookup in the back, but it is missing the circuit breaker. Fortunately, I do have this other box here. It is different, so I can't use it, but the circuit breaker here looks to be the same size dimensionally, and I know it is fused for the same amps as far as when it trips. So this is a usable fuse. We can swap it over as long as the wiring's the same. So I'm actually going to start here. I want to get this box open. We'll get this circuit breaker out and make sure it can be moved over to the other box. All right, well, this is very interesting. The fuse, the circuit breaker, has been bypassed. These connections here, there should be one on each tab, and then same thing with this right here. Someone just completely bypassed it. Why, I don't know, but all I can say is this panel came off a generator that had a stator that had melted down. It was a Briggs & Stratton stator, one of the ones that does not use an AVR, and those stators are very solid. This is actually the only stator I've ever pulled off that it had actually melted down. So yeah, now I guess I know why. Maybe someone was getting annoyed that the fuse kept tripping and they just bypassed it altogether and overloaded it, and the generator died. Very interesting. So there's the rating on the fuse. It says 20 amp. Delay 24, trip amps 27. So I want to double check the way this is wired. Right now it's shut to off, so we should not get a connection. I guess the question is the connection when you turn it on from here to here or here to there? Let's turn that on. Yeah, and it's straight across, so we'll just double check this one. We'll shut it off. Okay, good. All right, I don't know how this was originally wired, but I can see that these two wires right here, this gray and blue, are the ones coming up from the stator. So those need to be on separate circuits. And then these two wires here go over to the hut terminals on the 240 outlet. And judging by the length of these wires, this one's the shortest. So I'm going to put that on the closest tab. Put this on the other. And then we'll just do the same over here. We'll match up the colors, gray to gray, blue to blue, and that should be it. So I want to spend a second, just double check that the fuse is working and things are doing what they should. Now, there are a total of 5 terminals here. We got leg 1 diagonal and leg 2 the other way. And then this one here is the ground. So leg 1, one of these terminals should be connected to that switch. So we'll put it right there. And let's check. We'll turn this on. We'll check one of the hot wires here. And it's good. And we're good. And then up here actually will be dead because this is the other leg. So I have to move that alligator clip. I'm not sure which one it is, but it's either that one or this one. Yep, not that one. Okay. Okay, good. So everything's going properly through that circuit breaker. All right, so ready to move on. The rail here on the stator side is a little bit blown out right there. It's a pretty typical problem. And the rail itself is twisted a bit. So I'm going to give that a few taps, straighten it out the best I can, and then start putting this thing together. And that's the end result there. Going to install the bell housing now. These bolts do not have lock washers, so you do need a bit of a thread locker to hold these in place. I'm at a bit of a roadblock here. I don't seem to have the rotor bolt for this rotor, and I know I did, but this has been sitting around for at least a month, and I think that bolt worked its way into my spares pile. And I have plenty of spares, but they're either too long or too short. And recently I was working on another project. I needed to cut down a spare bolt to use it to push a rotor off. And I have a feeling that the one I cut is the one that I needed for this rotor. So unfortunately, I got to put an order in, and it's going to be a little while before I can finish this up. Well, something showed up in the mail today. It only took 3 days to get here, so not too bad. We'll get this thing out of the package and finish this up. I usually torque that rotor bolt down to about 23 foot-pounds on this setup. And you can fill the cylinder with rope to lock up the engine. I've done that quite a bit. You can also use a strap on the flywheel itself. In this case, I am going to pull the blower housing off and just get a wrench onto the flywheel nut. And that should hold things still enough in order to torque that rotor down to 23 foot-pounds. And before getting the stator on, there's no better time to clean these slip rings. This one here in particular is pretty dirty. To clean it, I just use a piece of Scotch-Brite. The only thing to be careful of is the wire that goes into the slip rings. There's one on each side. You don't want to knock into it and cause damage. Pretty close, but this stator is shorter and there is no hole for it. So it's like that on both sides. So what I'm going to do is just loosen one of the engine mounts, and that should allow me to pivot this kind of out of the way so I can add a hole there, and then this should drop in and bolt into place. So the stator is secured, and I've also resecured the engine mounts. This is a good time to get the spark plug out and just pull the engine over a few times. Make sure that the rotor is not scraping on that stator. Beautiful. And remember, the tab side goes in. That's pretty much it. This theoretically should be good to go. So I'm going to get it outside. We'll get it started up, make sure that everything is working. And if it is, we'll get it back inside and finish it up. All right, so before committing and starting this with gas, I'm going to pull the airbox cover off and just give it a squirt of starting fluid. I want to see that the electrical on this is good and that the light comes on before committing. Okay, good. So we're at 129.75 and 61.7. We're 120.4 volts. 60.1 hertz. We just lost power. All right, well now I know why someone bypassed this fuse. This fuse has issues. It actually popped once with no load. I wasn't recording at the time, so turned it back on. It seemed to hold pretty well. Loaded it to 3,000 watts, and it popped again. So I let it I reset it again, let it run at 3000 watt load for at least 5 or 10 minutes, and it didn't pop. But when I took the load off, I was just running it out of fuel, and the fuse popped again. So I'd say we need a new fuse. Unfortunately, these fuses are close to $80, and that doesn't include tax and shipping. So I think what I'm going to do is just get this back inside. We'll finish putting it together, and I think this one's going to have to be rolled into the corner until I get another one of these with a blown up engine that has a good fuse. So it's only been about 24 hours, and I've already located another generator that ran out of oil. Now, this engine block didn't survive, so it's not rebuildable. This is for parts only, and I've already harvested the part in question. So I'm going to get this out. We'll put this one in and get this back outside for another test. I'd call that a win. I ran it for about 10 minutes, no issues. So I'm going to get it back inside and finish it up. Well, that's pretty much it. We have a complete generator. And believe it or not, the parts used to put this together were actually from 5 separate generators. You know, the engine was the original one that came on the Husky. This Husky frame is the correct frame, but from a different Husky. And the power head and the outlet box actually came from 2 separate storm responder generators. And I didn't cover this really in the video, but the brushes I ended up using were ones that were damaged. They were missing a diode, so I did solder a new diode in place, and those work as well. So this thing, it looks good, it sounds good, and it makes power. So I hope this video helps someone. Thanks for watching.